Hello class, this video is going to focus on 1.5, which is locating points on a number line. There are two goals in this video. I can find a point on a directed line segment on a number line that is a given fractional distance from the initial point. And then also I can find a point that partitions a directed line segment on a number line in a given ratio. You want to open your textbook to page 35 where you will begin taking notes. So on page 35, we have a couple of definitions. So while a line segment has two endpoints, a directed line segment has an initial endpoint and a terminal endpoint. And for this, the initial endpoint is always going to be the one that comes first or is on the left side. So this is the initial endpoint. And then the one that is on the right side, that is our terminal endpoint. Okay, using a directed segment enables you to calculate the coordinate of an intermediary point, some fraction of the length of the segment, or a fractional distance from the initial endpoint. So using this line or segment, we can find a point that's anywhere between the initial and terminal endpoints, and the problems, they will tell you the fractional distance that you are looking for, and then you use that to find where the point is located. Okay, so here is our formal definition. So locating a point at fractional distances on a number line, we find the coordinate of a point that is a over b of the distance from point C to D. So the first step is to calculate the difference of the coordinates of point C and D. So again, C would be our initial point and T would be the terminal point. So for the initial point, that is always our x1. The terminal point is always our x2. Step 2, we would multiply the difference by the given fraction in the problem. The fractional distance is given by a over b times the quantity x2 minus x1. And then step 3, add the fractional distance to the coordinate of the initial point. So this is the formula that we are going to use to find that coordinate. Okay, example 1, we want to locate a point at a fractional distance. This is on page 36. So we want to find point B on segment AC that is 1/4 of the distance from A to C. So somewhere on here, a fourth of the way. Now we can kind of estimate a fourth of the way if we partition it into 4 different segments. So a fourth of the way is going to be kind of close to point A. So point A is going to be our x1. So x1 is -5. Point C is going to be our x2, and that is 7. And then the fraction they give us, so this fraction, that's our a over b. And then x1 is our first point. Okay, we are going to use the equation to calculate the coordinate of point B. So our equation is x1 plus a over b times the quantity x2 minus x1. So we are going to substitute the numbers into the equation. So we have x1 is -5. We've got x2 is 7. We've got a over b equals 1/4. So in place of x1, I'm going to put -5 plus a over b is 1/4 times the quantity x2 is 7 minus x1, which is -5. Okay, so then it's just doing the math, and you can use your calculator. You can type this in just like it's written into your calculator to get an answer. So I am going to just do the math. So 7 minus -5 because becomes 7 plus +5. 7 plus 5 is 12. 12 times 1/4 is 3. 3 plus -5 gives me -2. Okay, so that means point B is located at -2. So here is point B at -2. That is 1/4 of the way from A to C. Okay, example 2. This is on page 36. We have a biking problem. Julio is biking from his house to the library. His house is 8 blocks west of the school, and the library is 4 blocks east of the school. If he stops to rest 1/3 of the distance from his house to the library, at what point does he stop? So here's a picture for you. So we know Julio's house is the initial endpoint. So that's our x1. So that's at -8. And the library is the terminal endpoint. So that's our x2. And that is at 4. And the school is right by the library. And we are trying to find out where he's going to stop. So 1/3 of the way between his house and the library. So 1/3 of the way is going to be closer to x1. Okay, so we are going to substitute what we know into our equation. So in place of x1, we have -8 plus a over b is 1/3 because he wants to stop 1/3 of the way times the quantity. X2 is 4 minus x1 is -8. And then we just do the math. Again, you can type this right into your calculator the way it's written, or you can just do the math like I am. So 4 minus -8 becomes 4 plus 8, which is 12. 12 times 1/3 is 4. -8 plus 4 is -4. Okay, so that means he's going to stop at point -4. If I go back, so at -4, right here, this is where he's going to rest. Okay, so we have section formula on a number line. So if C has coordinate x1 and D has coordinate x2, so that means C is our initial endpoint and D is our terminal endpoint, then a point P that partitions the line segment, so divides the line segment in a ratio of m to n, is located at coordinate n x1 plus m x2, all divided by m plus n, where m is not equal to -n because we can't have 0 on the bottom. Okay, so this is the formula that we're going to use to find point P. So point P is a point that partitions the segment, so it just divides it in whatever ratio that they give you. Okay, so example 3, this is on page 37. Locate a point on a number line when given a ratio. So we want to find B on a segment AC such that the ratio of AB to BC is 3 to 4. So again, A is our initial or x1. C is the terminating or x2. And then we're going to use our formula and we're going to substitute the numbers that we have. Remember, M and N, those are the ratio that they give us. So they want a ratio of 3 to 4. So M is 3, N is 4. And then x1 and x2 are our initial and terminating points. And we're just going to substitute that into the equation. So n, we're going to substitute 4 times x1, which is -5, plus m, we're going to substitute 3 times x2, which is 7. And then on the bottom, we have m, which is 3, plus n, which is 4. And then again, you can use a calculator. You can put it in just like it's written, and it will give you your answer. I'm just going to do a quick little math. So we have 4 times -5, which is -20, plus 3 times 7 is 21. So -20 plus 21 is going to give me 1. And then 3 plus 4 is 7. So the point is going to be 1/7. Sorry, 1/7 on the number line. And you can see right here, point B is about 1/7 of the way between 0 and 1. Okay, so that is where we can partition our line in a 3-to-4 ratio. Okay, example 4. This is on page 38. We have a road trip. Jorge is traveling 2,563 miles from New York City to San Francisco by car. That is a far drive. He plans on stopping for gas when the ratio of the distance he has already traveled to the distance he still has to travel is 2-to-5. So how far has Jorge traveled when he stopped for gas? Okay, so we know a couple of things. We know M2N is 2 to 5. And then his initial starting point is going to be 0 because that's where he is when he starts. And then his terminal point is going to be 2,563 because that's how many miles it is to get to his destination. So we are going to substitute those into our equation. So n is 5, x1 is 0, plus m is 2, x2 is 2,563, and that's going to be over m2 plus n5. Now again, you can throw this all into your calculator. This time I am using a calculator, and I am just going to put in the fraction button and then throw everything on top, and then throw the stuff that's on the bottom, and then press equals. And when you do that, you should get 732.3 miles. So once he has traveled 732.3 miles from New York City, he's going to stop for gas. He still has a long way to go after that, but I think that's pretty good to make it that far without having to stop for gas. Okay, that is the end of 1.5a. Remember, you must get a 75% on the video for this, on the quiz for this video in order to move on to the practice.